Aha. Right, so first question. Oh, come on. Right. Ready to sleep? Me too. 100-gram apples falls with acceleration of 10 onto a sleeping physicist. How much force is the apple experiencing while it's falling? Okay, so the first question. There's my beautiful apple. Beautiful. Oh yeah, look at this. Look at this. Oh yeah, look at that. Strawberry, yeah. So the force is equal to the weight, which is equal to, what is force equal to ma, which is 0.100 times 10, which is equal to 1 Newton. So the force equals 1 Newton. Yeah? I was making a joke in question 1. Nobody saw my joke? No. A 100-gram apple falls on a sleeping physicist.
Yeah, the Newton joke.
Like you're supposed to, this falls on a sleeping physicist. There's the tree.
Bigger than the tree.
Yeah.
Is it Newton?
Yeah, this is my joke. This is supposed to be Newton.
Yeah.
And the apple hit his head with 1 Newton of force.
Yeah.
My joke.
Yes, I know.
Oh, great.
Like last time you asked in the.
And you didn't think it was funny last time either.
Yeah.
Yes. Okay. Fine. All right. A 2.5 kilogram ball is dropped from 49 meters. How much force is being applied to the ball as it falls? Okay, so again, this is just force equals weight, which equals mg. So I'm trying to trick you a little bit here. This isn't important information. You only care about what the mass is. So it's 2.5 times 9.81, which equals 24.5 newtons of force. So far okay?
Plus, minus, I use minus 9.81. Is it good?
That's fine, yeah. If you want to say force equals minus, that's good too. Yeah. So you could say force equals minus 24.5 newtons if you want to, and then if you wanted to say the weight is 24.5 newtons. I don't mind. Okay, 3. A car is being tested for safety. The 2,000 kilograms of car is driven by a test dummy. The car hits the wall at 20 meters per second. The front of the car, which is 1.1 meters long, begins to crumple, and then finally the car is brought to rest. Okay, so what's happening here is you have your car, and there's my car. That's the front of the car. Okay. Yeah. Oh no, I can draw that better. Yeah. So this is going at 20 meters per second, and then what happens? It hits the wall, and then the front of the car becomes crumpled. You see that?
Yeah.
So it's 0 meters per second. So while the car is touching the wall is given a huge force to the left to slow the car down. And I tell you also that the front of the car is 1.1 meters long. And then afterwards there's no car front left. So you could do a UVATS here. U is 20, V is 0, S is 1.1. And we want the A. So V squared equals U squared plus 2AS. Yep.
The question says the car hits the wall at 20 meters per second.
True, yeah. So what happens here, if you look,
Is it U or V?
That's you.
Why it's U?
Yeah, so the car's going at 20. Look.
Yeah.
So this is the front of the car.
It's not hit the wall.
Yeah, watch. It's going at 20.
Yeah.
20, 20, 20, 20, 20. And then it hits the wall. And then when it hits the wall, it slows down. So it goes 20, 19, 18, 17, 16, all the way down to 0, and then it stops. And then the front of the car gets compressed. So while the car is compressing,
Mm.
the wall is given a force that way
Yeah.
to stop the car. So the U is 20 and the V is 0. Does that make sense? Yeah?
Yeah.
And the S is 1.1. Yeah? Okay. So, let's see, 20 squared, yes, and then divided by 2, and then divided by 1.1. So I got here the A, will it be plus or minus?
Plus.
Will be
Minus.
yes, because
Minus?
it's decelerating.
Yeah, slowing down.
Yeah.
So, F equals MA, which equals, what did I say the mass was? 2000, wasn't it? 2000, wasn't it?
Yeah.
Yeah.
2000.
So that's a huge number of minus 363636 newtons. Or if you want, the force is minus 363.6 kilonewtons. Three six three
But
six three six.
last time you give the answer is plus.
Oh, it doesn't matter. It depends how I phrased it.
Because you
Yeah,
say
no, I'll tell you now.
decelerating, so
Yeah, but it's okay, Amanda, if you call left plus and right minus. I don't want you to worry too much about the signs. You can give the answer here as plus or minus. But because I actually say how much force is the wall applying, usually when we say how much, we don't care about the minus.
plus or minus.
Yeah, so we just say how much is 363.6 kilonewtons. But if I said what is the force, like this, then we do care about the plus or the minus more. But if I just say how much, I don't really care about the plus or the minus. Is that okay?
Yes.
Yeah?
Why the F is 1.1?
That's how big the front of the car is. So when the car hits the wall, the car still moves for 1.1 meter until the front of the car is all gone. It's crushed. Let me see if I can find a video here. So yeah, for this question here, you don't care about the distance the car travels to the wall. You don't care about that. You only care what happens at the wall, and the S is the distance here, as it's crashing into the wall.
Shall we change 200 kilograms to meter?
This?
Yes.
No, because it's mass. So you can keep it as kilograms. Car crashing into wall, test dummy.
What's dummy?
What's dummy? Ah, I'll show you now.
Oh, sorry.
Why do I get Top Gear presenters? Hang on.
Is it search for car crash test video?
Yeah,
Dummy thing.
test dummy. These are test dummies.
Dummy.
You know them?
No. Ugly.
Yes, ugly indeed. What did you say I should type
Crash
in?
test.
Crash test cars?
Yeah.
Yeah, this is what we're talking about.
No, but this is it goes under the lorry difference,
Huh?
right?
What's that?
No, never mind. Just say it.
Uh,
You see, it's crashing under the lorry.
this is some stupid long video. I don't want that. I just want a short one.
Then yeah, go to IIHS. It's yeah, it's that.
This
No,
one?
no, it's search IIHS in YouTube.
IIHS.
Yeah,
What's IIHS?
Institute of something Highway Safety.
Ah, okay. Okay. You want something like this?
Super
No, but that's it's explaining it. There are a lot of videos of this crashes.
I don't want explaining, huh? I know. Uh, car crash slow motion.
First one. Boom.
Ah, no. Well, this one is great looking, but I think this is the one I really want.
Boom.
Yes.
Jeep.
Jeep, yeah.
Police.
Not great, but you can see. No, that's terrible actually.
Why don't you go to the right? Can you move it to the right?
Yeah.
Okay, yeah, play that. No.
Yeah, I just want the. Oh, hang. No.
And then
Ah,
yeah, play that. It's gonna crash into a wall.
yeah. This is the one.
Yeah.
This is the one. Yes. Okay. Now that's fast. Firstly, now the slow motion. I'm sure. Right. Pause. Now, the car here is going at 20 meters per second,
Yeah.
and the force from the wall doesn't begin until the wall touches the car. You see, that's what I mean by the S is 1.1. And now the car, its speed is 0.
Wow.
So that's what these cars are made so that the front crumples and disappears. See, it's gone.
The car is easy to blow with.
Yeah. And that's done on purpose. And that's a crash dummy. Dummy, that's a dummy. Now notice, only the front of the car changes its shape. But if you see here, the rest of the car, its shape stays the same.
Yeah.
This is done on purpose. You want this front to be big, not to be small, because if you were to go back to the question here, imagine I change this number, I don't make it 1.1, imagine I make it half, 0.55 meters. How will my answer change? Will it get bigger or smaller? Does anyone know?
Bigger.
It'll get bigger. Because here, to find the A, look up, to find the A, you have to divide by S. So if you divide by a smaller number, the A will be bigger. And if the A is bigger, then the F is bigger. And if the F is bigger, that means it will hurt the person more. So in fact, you want this number to be big. You would like the S to be big, so that the force can be smaller.
The distance is mean that you crash the wall and just turn back?
No, it's how much the front of the car
Go.
change. Yeah. So like here, if I go, well, the video's gone, but from the video, it looked like maybe, what would you say, guys? How big did the car reduce?
Maybe a
50?
meter?
Maybe less in the video. So the front of the car, you saw it, the front of the car broke, it went.
Yeah.
Yeah.
Is
So
it
this
close?
is the S is how much it got smaller.
Ah.
Yeah.
So
Okay.
it's not the car.
It's not the length of the car. No, it's not how far the car moves. It's not how far the car travels. It's while it's crashing, how much it shrinks.
Change.
Change, yeah,
Speed.
yeah, yeah. Okay, can I go to the next question?
Yep.
Yep. An 80 kilogram space probe is traveling at 2 kilometers a second. It then accelerates for 3 seconds. The propulsion system is capable of 1 kilogram of thrust. How fast is the probe going after it accelerates? What did I get this question? Alright. Alright. What number is this now? 4, is it?
Yeah.
Yeah. Okay, so you have a space probe and it's going at 2 kilometers per second and its mass we don't know. Oh, we do know, sorry, 80 kilograms. And then what happens is they turn the engine on, and while the engine is on, you get a force of 1 kilonewton. So the force equals 1000 newtons. And this causes it to increase its speed. So 3 seconds later, how fast is it going? Yeah. Okay, so U equals 2000 meters per second. V we don't know. A we don't know. T we do know. S we don't know. So there seems like there's something missing, but there is a way I can get the A. How's that?
There.
I could say F equals MA. So I have 1000 equals 80A. So that means A equals 100 over 8, which is, what's that, 50 over 4, 12.5, is it? I think so.
It's
Isn't it?
Kinda, I think.
Yeah?
Yeah. Yeah, correct.
12.5?
Yeah.
So now I can get the, what do I want, the V. V equals U plus AT, which is 2000 plus 12.5 times 3, which is 2000 and what's that, 50, sorry, 25, 37.5. So we'll say 38 meters per second. Yep. Can I go to the next one?
Yes.
Did you get this right?
Yes.
Great. 5. A 75 kilogram man jumps from a height of 2 meters onto some grass. The man bends his knees when he lands and decelerates over a distance of 20 centimeters. How much force does his body feel? Okay, so this is a bit like the car. So he lands like this. Well, no, let's make it more realistic. So he jumps, and then he lands like this, and then he bends his legs like this. So when he lands, it's like when the car hits the wall, it slows down. So this distance here is 20 centimeters, and the height he jumps from is 2 meters. So we have to break this problem up into 2 halves. So first, we'll call it part A, when he's falling, and then part B, when he's landing. So A is from here to here, and then B is from here to here. Okay, so in the A picture, U, V, A, T, S, what's the U? 0. V we don't know, A is minus 9.81, T we don't know, and S is minus 2. Let's calculate the V. We can use V squared equals U squared plus 2AS.
The U 0?
Yeah.
Oh
Yeah.
yeah.
2 AS So I got here the V, and if you want to say down is negative minus 6.26 meters per second. Um, yes? Okay, so the next part is when he lands on the ground. And again, maybe I can find a video here to help. Okay, so I'm sure I can find a cat. Slow motion cat landing. Okay. Wait.
Oh.
Okay, wait.
Oh, cute.
So, the cat hasn't landed yet. Wait. Now, look. For the second part, B, that's from the point where he lands to the point where he stops moving. So in the video, it's from this point, and then you see
Yeah.
the cat is slowing down, its legs are bending, and then it is stopped. So that's what I mean for the second part, the slowing down part. So here, what's the U? It is minus 6.26 meters per second. And the V is 0. And the S, 0.2. And I would like the A. So I can use V squared equals U squared plus 2AS, and I'll get A equals V squared U squared divided by 2. So I get the A is positive 97.97. So practically 98, we'll say.
But it's slowing down, right?
Yes, but we're calling down negative, so slowing down it's upwards, it's positive. If you were to say as he falls that's a positive speed, then slowing down the acceleration will be negative. But because he's going down and down is negative, then slowing down is positive.
Oh, okay, I see.
Yeah.
Yeah.
Okay, so that's his acceleration. Let's calculate his force. F equals ma, and I tell you what his m is. It's 75 kilograms. So his m is 75 kilograms. Yeah, so you get about roughly, if you wanted to do it, it'd be 7.3 kilonewtons.
But can we just answer in Newton?
Yeah, that's fine. That's fine. Yeah.
Okay.
Okay. Now the second part here. If he bends his legs only 10 centimeters, do you think the force will increase or decrease?
Increase.
Increase. In fact, if the only difference is that this is 10, then it will change this, it'll be twice as big, because this number here will be half the size. So anyway, just to get straight to the answer, in the second part, if he only bends by 10 centimeters, the answer will be 14.6 kilonewtons. Okay, and the last part is do I want to do it? Did any of you try the last part?
Can you do it?
Okay.
Why is 44?
Sorry, do you need me to go back to this?
Yeah, why is 44?
I didn't do the calculation. All I did was, if you change this to 0.1 instead of 0.2, I didn't write it down. Sorry, Grace, this part here, In the second part he says it's 10 centimeters instead of 20. So if you change this from 20 to 10, then this number will be twice as big. And this number will also be twice as big. So this is the answer then. So for like part 1 you get this answer. And then for part 2 you get twice as big. Okay, can I do the last part? Not yet. Yeah? Okay. So for the last part you're working backwards. He can bend his legs 50 centimeters and the maximum force is 9 kilonewtons. So we're working backwards. So the force equals 9 kilonewtons. So that means the force is 9,000 newtons. But F is MA. That's 9,000. What's his mass? What was his mass? 90 kilos?
No.
Was he that heavy? No, he was only 75 kilos. So 75A equals 9,000. So A equals 9,000 divided by 75, which is 120 meters per second squared. The S is 50, the V is 0, and the U you don't know. So let's calculate the U. What formula? Let's see. V squared equals U squared plus 2AS. So that means the U the U is quite big. 100, no, that's too big, surely. That's too big. Oh yeah, I have to square root it. That's better.
Why is human sugar so cheap?
Why? I said in the question, didn't I? His mass is 75. Yeah. U equals 10.95 meters per second. Now remember, that's here, going from here to here. You have a U and then a 0. But for this part of the journey, the U will be the V, and here is 0. So let's do that part now. We're going backwards. So for the next part, U is 0, V is 10.95. Sorry, I should be extra careful here, that's a minus. 0, V is minus 10.95, A is minus 9.81, so now I can get my answer of S by again using V squared equals U squared plus 2AS. So S is 6.11 meters. So this is the maximum he could jump. Yeah? Sorry, yes, Grace? Yeah, so for this part here, we're doing this part. So the U is 0, and here is 10.95. So, the way I'm thinking about this is, there's two halves. So this is the landing part, and then this is the falling part. So in this part here, the U is not 0 and the V is 0, and then here the U is 0 and the V is definitely not 0. And then here, it's from here,
All the way.
yeah, to here. Is that okay? Alright, we'll look at the next questions. Can I close this?
Yes.
Are you sure?